Hello, dear students. I hope you are getting up well, picking up the topics in electrochemistry under Chemistry Everyday series. And now, the topic which we have to take up today is also related to electrochemistry, and the topic is a relation between equilibrium constant and free energy change of a system. Free energy change, how equilibrium constant Kc is related with the free energy change. Now, free energy change we have already learned is related to thermodynamics. And Kc, of course, we know that it is equilibrium constant. So let us take up, there is a very important relation which decides about certain factors such as spontaneity of a reaction, cell reaction, of course, and the equilibrium constant Kc for the cell reaction is derived directly from E naught cell. E naught cell is the standard electrode potential of the cell. Through the relationship free energy change under standard condition that is known as delta G naught is equal to, finally, as per common logarithm system, it is minus 2.303 RT log Kc. Kc is the equilibrium constant. Now let us see how this is derived and how we get it. It's a very important relation which helps us to determine the spontaneity of a reaction. And the standard free energy change, as I've already given you, is equal to minus 2.303 RT log Kc. This negative value has to be taken into consideration. और ये हम पढ़ चुके हैं that change in gives free energy for a chemical process. Thermodynamics में हमने पढ़ा हुआ है under the standard state free energy change is given by this relation delta G, that is the free energy change under any conditions of temperature and pressure, is equal to delta G naught, that is the free energy change under standard conditions of temperature and pressure, plus RT log Vero. ये Q की तरह दिखता है, लेकिन मैं आपको बता चुका हूँ ये Q नहीं है अंग्रेजी का, बड़ी अंग्रेजी का कैपिटल लेटर Q नहीं है. This is a Greek letter which is known as Vero. So RT ln means exponential logarithm or natural logarithm of reaction quotient, that is Q. And of course, we won't call it Q. We must learn that this is known as Vero, looking like Q. And in many books you will find almost similar to as Q, but please, my advice to you is that you learn the proper term here. And now the standard free energy change is represented like this. Now we shall derive a relation between standard free energy change and Kc. We know that equilibrium state, the reaction quotient becomes equal to Kc, equilibrium constant. ये हमने chemical equilibrium में पढ़ा है that reaction quotient जब equilibrium constant के बराबर हो जाता है, that is it attains in thermodynamic equilibrium, then put up the values into delta G naught becomes 0 at equilibrium state. That means a stable state, and the free energy change is also 0. And as we find here, Kc and the reaction quotient are also equal. So we substitute the values what I have given you earlier in equation 1. We get 0 is equal to delta G naught RT ln reaction quotient. And delta G naught, finally we can just perform a mathematical transfer, and we get that this becomes equal to delta G naught minus RT ln reaction quotient, Vero. And in terms of common logarithm, you have to multiply by 2.303. ये तो हमको मालूम है कि अगर exponential logarithm को common logarithm में means to the base 10 करना है तो 2.303 से हमें multiply कर देते हैं and we get the equation like this. So delta G naught is equal to minus 2.303 RT log Kc. This is final equation. Based upon this, we have to perform several questions. Maybe a MCQ type or even assertion decision type, but we have to be very careful about this equation. And next, we have to take up what is known as, I will say, keep certain points in your mind. And what are the points to be kept here, which you must always be prepared with, is the electrode potential of a cell is equal to E standard cell is equal to E naught cathode minus E naught anode. ये तो हम पढ़ चुके हैं, याद रखना चाहिए. And for spontaneous reaction, the E naught cell, that is standard electrode potential, must be positive. We have learned about Nernst equation also, and finally the Nernst equation comes out to be like this: E naught cell is equal to minus 0.059 log concentration of the products divided by the concentration of the reactants raised to respective powers. And E naught cell, ये भी हमने निकाल लिया है. Last time we have discussed about it. And here is the relation which we have already learned just now a little earlier. So these are the certain points we must keep in mind. It will make us convenient to solve several questions relating to electrode potential and delta G. So same thing. If you summarize, you can put it in a triangular form, that delta G naught, E naught cell, and the equilibrium constant, how they are related. And here are the equations we have learned about. And this table, which I have planned for you, is very important. That gives you an idea about the spontaneity of a reaction. K एक से कम एक से ज्यादा होगा तो डेल्टा जी नॉट कम होगा, ई नॉट सेल ज्यादा होगा जीरो से, and the reaction will be spontaneous. So these conditions you need to know. When anything becomes equal, it is at equilibrium. So non-spontaneous reaction कब होगा, spontaneous कब होगा, इससे हम बड़ी आसानी से निकाल सकते हैं. Please, you have to keep it in mind and learn it. Okay, next time we are coming soon, and next time it will be electrochemistry part 7, and the topics to be taken up are very important, and these topics are not related to electrochemical cell, but these are Arrhenius theory of ionization and electrolytic dissociation, along with ionic conductance in solutions. So we should be back very soon. Please do not forget to hit the subscribe button to our channel. Thank you very much.